We are talking about special right triangles, and in this case, we're talking about 30 degree, 60 degree, 90 degree triangles, or 30, 60, 90 triangles. And we want to use properties of 30, 60, 90 triangles to solve problems. So just like with the 45, 45, 90, we had special relationships or special equations that we could use. We have the same thing when it comes to the 30, 60, 90 triangle. It is a right triangle where the hypotenuse is 2 times the longer than the short leg, and the long leg is square root of 3 times longer than the short leg. So we have an example here. And again, we have a 90-degree angle right here. And that means that our hypotenuse is opposite the right angle. So that's our hypotenuse there. And our short side is opposite the 30 degrees. And our long side is opposite the 60 degrees. So we don't have a relationship necessarily. We're going to write all of the equations in terms of the short side. So in this case, the short side is just equal to the short side. And the hypotenuse is 2 times longer. We'll do the leg next. The long leg, which would be right here, and that is going to be equal to the square root of 3 times the short leg. So we're going to take whatever the short leg is from up here, so that's the short leg, and we're going to multiply that by the square root of 3. And our last example for the hypotenuse is 2 times the short leg. So hypotenuse is equal to 2 multiplied by s, or the short leg. And then we'll use those relationships to solve problems using the 30, 60, 90 triangle. Now here's a quick proof of how the 30, 60, 90 triangle exists. So this is an equilateral triangle. I'm just telling you that. So that's the statement. This is an equilateral triangle. So what that means is all the sides are congruent. So all the sides are 10. Now we also have a angle bisector right here. So that's cutting that angle in half. And that's going to be important. And that is also the altitude. So this is a 90-degree angle right there. So 190-degree angle. Now, in an equilateral triangle, all the angles are congruent. So we could say 180 is equal to x plus x plus x, because we don't know what the angle measurement is, so we can just represent them all with x's because we know that all of the major angles are equal. So we say 180 is equal to 3x, and we can divide by 3, and we get 60 is equal to x. So each angle is equal to 60 degrees. So this is 60 degrees, that's 90, this is 60. And we already said that that's an angle bisector. So if that's an angle bisector, 60 divided by 2 means that this angle is 30 degrees. So hopefully we can see our triangle here. that was derived from an equilateral triangle where we have 30, 60, 90 triangle right there. So let's think about what that means. If this is a perpendicular bisector and an altitude, so if it's a perpendicular bisector, that means it bisects this in half. So if the full length is 10, then we can have 10 divided by 2, which is equal to 5. So our short side is going to be equal to 5. Our long side, we don't know what that is just yet. So we'll have to calculate that one. But this is going to be our long side. And our hypotenuse is 10. So we're going to use Pythagorean theorem, and that's going to be c squared is equal to the sum of the other two sides squared. So we have a squared, and then we have b squared. And we can substitute in the values that we know. So we know the hypotenuse is 10 squared, and we know the short side is a squared, or 5 squared. And we do not know what b squared is, but b squared is our L value that we're trying to establish. So we can solve this, and we get 100 is equal to 25 plus L squared. 5 squared is 25, and L squared. Now we're going back to GEMDAS. So we're going to subtract 25, and then we get 75 is equal to L squared. And then we want to take the square root of both sides to get rid of that square over the L. And we get, that's going to be 25. That's going to be 5. 25 times 3. Still under the radical. Over here, the square and the square root cancel, and we're left with L. We do know the square root of 25 is 5. So we're going to get 5 times the square root of 3 is equal to L. So using a value of 10, the side for the equilateral triangle, we were able to calculate the small side was equal to 5. The long side is equal to the square root of 3 times the short side, which happens to be 5. And our hypotenuse is just 10 because that was the relationship, because it's equilateral triangle. But then we have the short side is 5. 2 times 5 is 10. So then that relationship still holds. Now we want to use these equations to answer the next 5 questions. So number 1, we need to find x and we need to find y. So there's a few things we need to establish. What are all of the things in this problem? So where's the right angle? The right angle is right here. So y is actually going to be our h value. Then the side opposite the 30-degree angle, that's going to be the short side. So the short side is equal to 8, and that means the long side is equal to x. So we can solve a few of these things. The hypotenuse is pretty straightforward in this case. So hypotenuse is equal to 2 times the short side. So the hypotenuse is equal to 2 times 8. So the hypotenuse is equal to 16. So the hypotenuse is equal to 16. And so that means that that is goes right here. So our y value is also equal to 16. So we have one side left to calculate, and that is the long side. And the long side, or the long leg, is going to be equal to s times the square root of 3. So we can substitute the short side in, and we get L is equal to 8 times the square root of 3. So that is also says that our y value is that, and our x value, oh, that is our x value. This was our x value. Our x value is equal to the long leg, and our hypotenuse is equal to the y value. Next one we have another 30, 60, 90 triangle. So we identify the hypotenuse. And again, we are given the short side. So the short side is equal to 4 square root of 3. So we can calculate the hypotenuse, which in this case is going to be the same equation that we used previously, where the hypotenuse is equal to 2 times the short side. So we can substitute these values in, and we get h is equal to 2 times 4 square root of 3. Two times 4 square root of 3, and we get h is equal to 8 square root of 3. H is also our hypotenuse, so that also means y is equal to 8 square root of 3. Now we just have to find the long side, or the long leg. And so the equation is L is equal to S, or the short side, times the square root of 3. So we can substitute in the values that we know. We know that we're looking for x in this case, and then x is equal to 4 times the square root of 3 and the square root of 3. And then anytime we multiply two of the same values together, 3 times 3 is going to be 9. So we're going to get x equals 4 multiplied by the square root of 9. But we know that the square root of 9 is 3. So x is equal to 4 times 3. And so that is equal to 12. So we also know that x is equal to 12. Those are two answers there. Then we're going to number 3. And we have 30, 60, 90 triangle. This time they give us the hypotenuse. So we're going to have to kind of work backwards. We know that they give us the hypotenuse because we know that the hypotenuse is always opposite the 90-degree angle. We know that in this case, y is equal to the long side and x is equal to the short side. So we can use the formula, which is h is equal to 2 times the short side. And we can substitute the values in that we know. We know that the hypotenuse is 6. We know that the 2 is constant. And we're trying to find x because x is representing the short side. So we can divide both sides by 2. And we get 3 is equal to x. Next, we want to find the long side. So we have the long side is equal to s times the square root of 3. So we can just substitute in side, which we just calculated. And also L is going to be our y value. So y is equal to 3 times the square root of 3. And so that is our solution. So we get y is equal to 3 times the square root of 3. Next, we have example 4. And we are given that this is a 90-degree angle. So we know that y is the hypotenuse. Because the 30-degree angle is here, we know x is the short side. And we know that 5 square root of 3 is the long side. So we don't have any relationship really between the long side and the hypotenuse. So we have to use the long side to calculate s. And the equation is L is equal to s times the square root of 3. And we were told that our L is equal to 5 square root of 3, so we're going to substitute that in. So 5 times the square root of 3 is equal to x times the square root of 3. So on the right-hand side, we have multiplication. We want to get x by itself. So we divide by the square root of 3, and we divide by the square root of 3. So then our square root of 3's cancel on both sides, and we get 5 is equal to x. And then now we want to use that value to calculate our hypotenuse. So our hypotenuse is equal to 2 times the value of s. And we calculated already that our short side was 5. So we're going to substitute 5 in for S. So the hypotenuse is equal to 2 times 5. So then we get H is equal to 10, which is also our Y value. Then we have one more question to work on. An equilateral triangle has an altitude length of 12 feet. Determine the length of a side of the triangle, and it suggests that we sketch the triangle first. So I'm going to use this little sketch tool here, try to make an equilateral triangle. It may not work out exactly, but try to get it close. Okay. And it tells us that it has an altitude of 12 feet. So I'm going to draw that on there, an altitude of 12 feet. And that's 90 degrees, and that's 12 feet. So now we want to find the other values. Because this is an equilateral triangle, we know that all sides are congruent. And because it's an equilateral triangle, we know that we have a 30, 60, 90. This is going to be 60 degrees, and this is going to be 30 degrees. So we can see that we have a 30, 60, 90 triangle right here. And we want to find the other couple sides. Determine the length of a side of the triangle. So all we have to do is we just have to figure out what our hypotenuse is equal to. But there is no relationship that directly correlates the long leg to the hypotenuse. So we have to calculate the short side first. So we can use the equation H is equal to 2 times the square root of S. Or, excuse me, 2 times S. So here's our hypotenuse. We don't know the short side yet. So now we're going to have to use the long side. So the long side is equal to S times the square root of 3. Okay, we know what the long side is. That was 12. So 12 is equal to S times the square root of 3. So we want to get S by itself, so we divide by the square root of 3. And then we get 12 square root of 3 is equal to S. We don't like the square root of 3 in the denominator, so we're going to multiply by the square root of 3 over the square root of 3. That's like multiplying by 1, but the nice thing is the denominator drops the radical, and so we are going to be left with 12 times the square root of 3 over 3. Now, our 12 can be canceled by the 3, and we're left with 4. So we get 4 square root of 3. That is equal to our short side. Then, once we have our short side, we can substitute that back in and we can find out what our hypotenuse is. So x is equal to 2 times 4 square root of 3. And then we can just say 2 times 4 is going to give us 8. So x is equal to 8 times the square root of 3.